first half of the 20th century has been the era of the information explosion. Data handling techniques, undreamt of 50 years ago, have made an impact on every area of leisure and business activity. But it is the ability to transmit electronic information across long distances at high speed which is realizing the full potential of this revolution. Over the last decade, British Telecom have been laying the groundwork for the introduction of System X, a radical departure in communications techniques, which is beginning not only to revolutionize Britain's telephone services and data communications, but also to provide an ideal medium for view data and facsimile transmission, the electronic mail of the future. System X is, in essence, a computerized digital telephone exchange which can give British Telecom's extensive communications network the ability to function more efficiently than ever before. Automatic telephone exchanges connect individual subscribers to one another using various forms of switch, whose design has changed radically over the years. The earliest automatic switches were the Strowger type, still widely used. Progressive development has led to the modern electronic exchange, which still, however, incorporates an element of mechanical switching in the form of reed relays. And all mechanical methods are, to a greater or lesser extent, subject to wear and corrosion, and consequent interference on the line. The technical basis of System X lies in the digital methods which permeate every level of its functioning. The traditional analog method of voice transmission, as its name suggests, relies upon an electrical signal which is a direct model of the original sound waves impinging on the telephone mouthpiece. After traveling across country, via many stages of switching and amplification, this signal inevitably suffers distortion and an unpredictable degree of volume loss. Digitalization, on the other hand, involves making repeated measurements of the sound wave thousands of times every second. It is thereby converted into a series of numbers, each of which is transmitted down the line as a pattern of pulses. Whatever hurdles this signal encounters in transit, the crucial information remains intact. Each successive exchange along the route can then recognize the pattern and relay a clean version of the digital signal, which is ultimately reformed into a faithful reproduction of the original sound. But it is not only the transmission of signals which is digital. The function of switching them through to the correct lines is also performed by digital electronics. Miniaturized solid-state circuits have led to a new standard of fast, reliable, interference-free transmission, allowing efficient data links as well as high-quality voice communication. System X uses these circuits to compress signals into minute time segments, each of less than a millionth of a second, thereby squeezing a number of signals into a single line. By precise sorting and timing, the segments are ordered into a sequence which enables them to be switched through to their respective destinations. Unlike traditional switching, where a physical contact persists for the duration of a call, we now have a rapid and complex digital switching process, which is continually reordering and routing highly condensed composite signals. But in addition to the attainment of a far more efficient use of the network, the miniaturization of circuitry in System X leads to a dramatic reduction in the size of exchange equipment. Such rapid and smooth conversion is possible through an innovative approach to the overall system design. It is fundamental to the thinking behind System X that it has been conceived as a series of building blocks, or modules, each with its own individual function. Examples of these functions are the digital processing of control signals, such as dial pulses or press button tones, the efficient routing of calls across country, and the switching which sets up these routes. There are even modules to oversee all the others and ensure that they're working correctly, and to communicate this information to a supervising engineer. Each major installation within System X can then be built from different combinations of a set of readily available modules, whether it be a small local exchange, a larger exchange, or a trunk switching center, and so overhead costs are enormously reduced. But during the changeover period, there will be further modules with the sole function of enabling System X exchanges to work in conjunction with the existing ones. These will facilitate a smooth transition until conversion is complete early next century. But the enormous flexibility of System X stems also from its use of integral computers or microprocessors. Much of the design work, therefore, involves the writing of computer programs, as well as the design of electronic circuits. These programs are also constructed on a modular basis, in line with the most modern techniques of computer programming. Thus, we have software as well as hardware modules, giving System X the advantage of British excellence in software design, and more importantly, allowing the addition of entirely new functions to the system simply by writing the necessary program modules and plugging them in. Working System X exchanges are already providing some subscribers with a range of extra services. Examples are three-party conversations, the ability to call frequently used numbers by short codes, and the automatic diversion of calls to an alternative number when required. Perhaps one of the most novel features is System X's unique voice guidance, using a voice recorded not on tape, but in the system's latest generation electronic memories.
Diversion service. Dial the telephone number to which you want your calls diverted, followed by square.
System X's flexibility in meeting future market demands through the addition of such services is only one of the features which give British Telecom a unique advantage in this newly competitive industry. The built-in intelligence of System X allows the transfer of highly sophisticated control signals between exchanges across the country. Thus, they're not isolated units, but can work as a truly integrated whole. As the new system is extended, the scope of the new services will be widened. For example, to reach a distant engaged number, it will not be necessary to try repeatedly. A simple instruction code will cause the distant exchange to monitor the required number and signal the local exchange when it's free, both exchanges then setting up the required call. By thus exploiting advanced design techniques, as well as utilizing the full geographical extent of British Telecom's network, System X has a uniquely competitive potential for domestic and commercial applications alike. For example, with the increasing portability of computer power, there will be demands for high-speed data links from locations anywhere in the country. Only System X can provide these. Just as automatic mechanical switching, originally conceived in the 19th century, successfully survived the challenge of the 20th, so System X will enable British Telecom to serve the needs of the 21st century, not merely adequately, but with a highly economic and competitive product.